So what we're going to look at now is the fire protection system and detection system. So what we have is an engine and APU fire detection and fire protection system. So for the two engines, we have two fire sensing elements that come together to form a single loop, if you like, monitored by a dedicated control module for each engine. For the APU, we have a single fire sensing loop wrapped around the APU, and again it's got its own dedicated control module to monitor it. And then for the other engine, same as before. When an engine fire or an overheat condition is detected, the control module will release the fire signal and we get the fire warning alarm and all the bells and whistles and the appropriate ICAS messages. The detection system is powered for all of these, both engines, and the APU is powered all off the essential bus. For the engine fire protection, that's the fire extinguishers, they're powered off the hot battery buzzes, and the APU fire extinguisher, the cartridge, is powered off the essential bus. So for the engine fire detection system, we have two sensing elements, one wrapped around the outer bypass struts and around the accessory gearbox on the engine, and the other one in the pylon. But the control module doesn't differentiate between the two, so it will just release a single engine fire warning message. The fire detector is a Systron Donner type comprising of a sealed tube charged with a helium gas and at the other end a responder unit, and the responder unit contains two pressure switches, an alarm switch and an integrity switch. The integrity switch is normally closed, held in the closed position by the residual pressure in the sensing tube, and the alarm switch is normally open and will close when pressure increases as a result of an overheat condition. If the fire sensor element gets ruptured and the helium gas escapes, that will cause the integrity switch to open, and the control module will see that and generate an engine fire detector fail CAS message. The control modules for the engines are in the left and right side consoles respectively for the left engine 1 and 2. And the fire bottles are in the compartment behind the rear electrical compartment in the non-pressurized area. In this photo you can see the two engine fire bottles and the single APU fire bottle. If we have a fire, then the action is to pull down the fire handle. It rotates downwards, and that action will cause the engine to shut down because the fuel shutoff valve closes, the hydraulic shutoff valve closes, the bleed system will shut down, and the engine will shut down. In order to fire the fire bottle, you then twist the handle. You can twist it in either direction. Each time you twist it, it will fire one of the fire bottles. You get 2 attempts to put out the fire. You'll see up on the between the two engine fire handles, you'll see an engine fire test switch. That tests the engine fire detection system, the APU fire detection system, and also the baggage fire protection system if you have it. So for the engine fire system, we've got 2 fire bottles. Each fire bottle has 2 electric squibs, allowing us to discharge either bottle into either engine. So you pull the fire hand down, twist it, it fires one of the squibs on one of the bottles into the engine that you've pulled, twist it in the other direction, and it fires the other squib on the other bottle into the same engine. And that's your 2 shots gone. The APU is just a single shot. And that's operated by pushing the red guarded switch that's got APU marked on it. You lift the guard, push the switch, and that fires a single squib, discharges into the APU. There's a pressure switch on the engine fire bottles, so once a bottle is being discharged, you'll get an ICAS message to tell you it's being discharged, but there's also a visual pressure gauge on the bottle itself. So these are all the ICAS messages associated with the fire. So we've got the engine 1, 2 fire message, red warning, APU fire message, red warning. Then we've got some caution messages for the fire detector fail, a fire bottle in op once it's been discharged, or APU fire detector fail. There's also another message that comes on there on aircraft that have got the baggage fire detection system. So you've got a baggage smoke message as well. And actually, while we're talking about that sort of thing, there's also a lav smoke message as well for the lavatory. APU fire detector is similar to the engine. It's just a single loop though wrapped around the APU compartment, and that goes off to its dedicated control module, generates the APU fire message. And by the way, if the APU is on the ground and if the fire happens on the ground and the APU is running, the APU auto shuts down after 10 seconds. The fire bottle doesn't discharge, but the APU will shut down. APU control module in the left-hand side console, similar looking to the engine one. For the toilet, we have a smoke detector in the toilet, and that generates a CAS message in for the flight crew and an audible alarm for the cabin crew. And that's this panel here. This is for the aircraft that are configured as a commercial airliner. So smoke detectors in the roof of the toilet compartment. Also in the roof of the toilet, also in the toilet compartment, we have a standalone, completely standalone fire extinguishing bottle that automatically discharges into the waste bin if there's a fire in the waste bin. Completely automatic. The end of the tube, of the discharge tube, is sealed normally with like a wax seal. If there's a fire, that wax melts, allowing the bottle to empty into the waste bin. Okay, there it is there. There's no electrical interface at all. The only thing that crew need to do is just do a visual check of the contents. So there's a contents gauge on there, and for convenience, because you can't see the contents gauge where it's situated, they've put a mirror, make it easier to see. So some aircraft have a smoke detector in the cargo bay. Some aircraft have a smoke detector and an extinguishing system. So this picture shows the aircraft with an extinguishing system as well. So if a smoke is detected in the cargo bay, you get a baggage smoke message. And if you've got the fire extinguishers, the crew can then elect to operate the fire bottles. So next to the APU fire bottle and next to the test switch, there's a cargo compartment push button switch, which they push. And that will operate the 2 fire bottles for the cargo bay. There are 2 fire bottles in the cargo bay, a metering bottle and a high rate bottle. The metering bottle is larger, the high rate bottle is smaller. Both contain a squib cartridge, and when you hit the fire extinguishing button, both cartridges will operate simultaneously. The high rate bottle will discharge its contents into the cargo bay in a matter of a few seconds. The metering bottle, which discharges simultaneously, but the contents of the metering bottle passes through a metering orifice, which basically slows down the discharge rate. So the metering bottle will discharge over a period of about 45 minutes. So the high rate bottle puts the fire out, and the metering bottle will suppress anything that's smouldering away and stopping it reigniting. The 2 cargo fire extinguisher bottles are in the rear avionics compartment, as we can see here. So this is in the pressurized area. And the contents of the fire bottles, it passes into the cargo bay and is discharged through 4 discharge nozzles in the roof of the cargo compartment.